18. Hello, welcome. Let's look at these JAMB mathematics past question for 2018. Please hit the subscribe button to subscribe to our channel so that you can be getting learning materials to prepare for your JAMB. The JAMB is fast approaching, and in our channel we'll make a lot of lectures and past questions for you to learn, very educating ones. So let's start with number 1. Express the product of 0.00043 and 2000 in standard form. A, 8.6 times 10. B, 8.6 times 10 to the power minus 3. C, 8.3 times 10 to the power minus 2. D, 8.6 times 10 to the power minus 1. So how do we solve this? We want to get the product of these and at the same time put it in standard form. So to get the product, we have 0.00043 times 2000. So we are supposed to find the product of this. Now naturally, if you want to multiply a decimal with a normal number like this, you can say that this goes with this. Now this goes with this, and this goes with this, so that you now have only 0.43 times 2, and we know that 0.43 times 2 is the same thing as saying 0.86. So that is what we are left with. Now to convert 0.6 in standard form, we can say that this is the same thing as saying if you take this point here and go over by 1, you now have 8.6 times 10 to the power minus 1. So 8.6 times 10 to the power minus 1, that is the answer, and that is why D is the answer, and that's why I marked it in red. So my answers are in red. Now number 2, simplify 2 sod 2 minus sod 3. That is the actual way it is written. This is not there. All over sod 2 plus sod 3. So that is what you are told to simplify. Now if you want to simplify any expression like this, you must have to multiply the up and the down by the conjugate of the denominator. So what is the conjugate of this denominator? The conjugate is sod 2 minus sod 3. So once you have sod 2 plus sod 3, just change the sign. It becomes a conjugate. So you also multiply it down by the same thing, sod 2 minus sod 3. So when you multiply out, what are you going to have? You have this times this will give us 2, because we have sod 2 here and we have sod 2 here. So 2 times sod 2 is 2. So we have 2 times 2, which will give us 4. Now you will now do this times this. This will give us, what would that give us? What would this times this give us? What would 2 sod 2 times sod 2? What will it give us? So it's going to give us minus 2 sod 6. Now we also multiply now this times this, sod 3 times sod 2. It will give us what? Plus sod 6. Now sod 3 times sod 3 will give us normal 3. So this will give us plus 3. So that's what we're going to have all over. If you're multiplying two conjugates, you're going to have the first one squared minus the second one squared. So the first one is sod 2. So squared is going to be 2 minus sod 3 squared is going to be 3. So that we now have 2 times 2 will give us 4 minus 2 sod 6 plus sod 6 plus 3 all over 2 minus 3. So 4 plus 3 is going to give us 7 minus Minus 2 plus 1 sod 6 is going to give us 3 sod 6. Please, this is minus. So you're going to be minus 2 minus 1. So minus 2 minus 1 is going to give us 3 sod 6. So all over 2 times 2 minus 1 is minus 1. So if you bring this down, it will give us minus 7 because of this minus, plus minus times plus 3 sod 6. This is 6. So this is the answer. So if you put this in other way, you can have it to be 3 sod 6 minus 7, which is this B that we have as the answer. So take note of this. It is very, very important. Now let's look at number 3 question. We have GT, if GT squared minus U minus W is equal to 0, make G the subject of the formula. To do this, you can take the other things to the other side so that we have only the one you want to make the subject. GT equal to, take U over, instead of minus U is going to be plus U, take W over, instead of minus W is going to be plus W. So you can then divide through by T squared. Divide through by T squared. So you have T squared, cancel T squared. So you have only G equal to U plus W all over T squared. So that is your answer. So here you have U plus minus W. This is actually supposed to be plus W all over T squared, making B this answer. Now for this number 4 question, we have find the value of K if y minus 1 is a factor of y to power 3 plus 4y squared plus k minus 6. Now whenever you're told that y minus 1 is a factor, it simply means that y is equal to 1, because you take this to the other side, it becomes 1. So now given y3 plus 4y squared plus k minus 6, that is this. So if you're putting the factors, anywhere you see y, you put 1. So you're going to have 1 to power 3 plus 4 bracket 1 squared plus k, which you don't know, minus 6 equal to 0. So that's how you do it. Now 1 to power 3 is the same thing as 1 plus 1 to power 2 is 1 times 4, 4 plus k here minus 6 equal to 0. Now take every other thing to the other side, leaving only k, so that therefore we have k to be equal to 1 plus 4 is 5. 5 minus 6 is minus 1. So you have k minus 1. Then take the minus 1 over to this side, it becomes 1. So you have k to be equal to 1. So making the answer to this problem. Please, if you like this, hit the subscribe button. If you have any questions on this, please drop it on the comment section. Please like our videos and share them, and support us in any way that you can. Thank you, and God bless you. No need to even bow, sir. Don't come on. For Physics 2018. The number one question. The SI unit of sound energy is A. Hertz, Hz, B. Candela, CD, C. Decibel, dB, D. Joules, J. So what is the SI unit for sound energy? Now, for us to understand this very well, we need to take note of very important aspect of solving this problem. Now, the SI unit for energy in general is joules. Now, since the SI unit for energy in general is joules, then sound energy is a form of energy. So the SI unit for sound energy is joules, and that makes D the answer. Now, for more clarity, we are going to look at the SI unit for the other quantities that have these other ones. So let's look at Hertz first. Hz is the unit for frequency. CD, also known as candela, is the unit for luminous intensity. In case if you see the question in another form, that's what CD is for. Now, dB, also called decibel, is the unit for relative loudness of sounds. That's what it is for. So some people might want to pick decibels, but it's not actually decibel, because decibel is the unit for relative loudness of sound. But if you talk about sound energy, the unit is joules. So you can see this. Hertz is for frequency. Candela, CD, is for luminous intensity. Decibel, dB, is for relative loudness of sound. So take note. So the right answer is joules, which is the unit for energy, because energy is involved, and the type of energy we are looking at is sound energy. Thank you. Now let's look at question number 2 for physics. WAEC past question for 2018. The general definition of elastic modulus is A. Stress over strain, B. Strain over stress, C. Stress times strain, D. Square root of stress over strain. So what is the answer to this problem? For us to understand this problem, we need to understand the simple statement of Hooke's law. So we're going to look at Hooke's law, which states that stress is proportional to strain, provided elastic limit is not exceeded. That's the statement of the Hooke's law, that stress, if you want to put it mathematically, you say stress is what? Proportional. Stress is proportional to strain. And once you have such mathematical representation, you can introduce a constant. So introducing the constant of proportionality, very, very important. If you want to change your proportional sign into equal to sign, you must introduce the constant of proportionality. And this constant for this case is known as Young's modulus of elasticity. That's the name of the constant that we are going to be using in this case. So if you introduce it, you can now say that stress is equal to constant, which is Young's modulus of elasticity, times strain. That's what you have. So making y the subject, you can now have that y, Young's modulus, is equal to cross multiply. So you have stress over strain, and that is the elastic modulus. So the right answer is A, which is what? Stress over strain, and that is the statement of Hooke's law. So in essence, y, which is elastic modulus, is equal to stress over strain. Very, very important. So you can be using this to solve some problems. And we also know that stress is simply equal to force over area. And we know that strain is equals to the extension all over the original length. So with this problem, with this equation, you can solve a whole lot of problem using the elastic modulus, stress and strain. So this expression is the same thing as saying force over area all over the increase in length, which I will call here extension, all over the original length. So that is the statement of Hooke's law explained more, where the elastic modulus is equal to stress over strain, because both of them are proportional. So that is the answer. Thank you. Yes, let's look at this question number 3 for WAEC Physics 2018. The diagram illustrates a simple barometer. Which distance measures the atmosphere pressure? A. PQ, B. QR, C. RS, D. QS. So which of these distances measure the atmospheric pressure? Is it this PQ? Is it QR? Is it RS? Or is it QS? So which of them? For us to understand this much better, I'm gonna make this very diagram again, and it's basically something like this. With inverted tube, then we're gonna have the mercury. This is the mercury, and it's inside this tube up to a limit. So you have the atmospheric pressure acting downward, pushing this mercury. So when it pushes this mercury, it's going to move into this. So here is vacuum, whereas this very height here is the height that is taken, and this height is actually equal to, for normal at sea level, 760 millimeter mercury. Millimeter mercury because we measure millimeters of this mercury that is inside. So the height from here to here is actually the height of the atmosphere, which is this atmospheric pressure. So when you look at this, you see that here is P, here is Q, here is R, and here is S. So the actual height is QR. That makes B the answer to this problem, because B is where we have QR. So QR is B. That is the answer to this problem. QR. So that is the answer. Thank you. Now let's look at question number 4 for Physics WAEC 2018. The property of a body to remain at rest or to continue in a uniform motion in a straight line is called A. Momentum, B. Inertia, C. Impulse, D. Energy. So what is that property of a body that makes it to want to remain in a state of rest if it is resting, or to continue in a uniform motion in a straight line when it's moving? What is that property? We all know that this property is inertia, because that's the definition of inertia. But I will also explain the other options. So let's take the definition of inertia first. Inertia is that very property of a body that makes it to do what? To remain at rest or to continue in a uniform motion in a what? Straight line. Rectilinear motion in a straight line. So that is what inertia is. Now let's look at other things like energy. Why did we say the answer is not energy? Energy is simply the what? Ability or capacity to do work. Ability of a body or its capacity to do work. And it's actually force taken through a distance. Now, what is impulse? Impulse is the force, the impact of a force at a particular time or for a number of times. That's force times time. That's what impulse is. And momentum, what is the meaning of momentum? Momentum is simply the product of mass times what? Product of mass and velocity. So you see that none of these three is this, but inertia is this actually the definition of inertia. And that's why inertia is the right option for this problem.
When you start, then you try out your own simple project already. You're already comfortable with it. Now
let's look at question number 5 for WAEC Physics 2018. During a training session, 2 footballers pass a ball repeatedly between each other. The to and fro motion of the ball is not simple harmonic because the I, acceleration of the ball, is not directed towards a fixed point. I, restoring force, is not directed towards the center. Acceleration of the ball is not directly proportional to the displacement from a fixed point. Which of the statements above are correct? A, 1 and I only. B, I and I only. C, I and I only. D, I and I. So what could be the answer to this? Now, for us to understand it, we need to understand what a simple harmonic motion is. What are the examples of simple harmonic motion? From what we learned, we know that a simple pendulum is an example of simple harmonic motion. And we all know what a simple pendulum is. When you have a rope and you tie a load to it, this is the load. So when you plug this load like this, it's going to make this motion. So it will continue to move like this, continue to move. And the acceleration of this ball is directed towards the middle. It's making this motion over a fixed point. Then another form of simple harmonic motion is when you have a helical spring and you attach a load to this helical spring. When you tap this load small, you see this thing will start vibrating. It will start moving from one point to the other. It will start moving like this, and as it's making this motion, the acceleration is also directed towards a fixed point. Just like this one is directed towards this fixed point at the middle. Now, when you have your guitar, you have your guitar, you have the guitar strings that move and are attached to this point. Now when you pluck your guitar palm, it will start vibrating over a fixed point. So all these motions, both that of a simple pendulum, the helical spring, and a plucked guitar string, plucked guitar string, all of them make what we call a simple harmonic motion. Now, one very important attribute of a simple harmonic motion is that the acceleration of the load or the string in this time is directed towards a fixed point. Very, very important. And another aspect of simple harmonic motion is that the acceleration of the string or the load in this our case is not is actually proportional to the displacement from the fixed point. So these are the two things that can make something a simple harmonic motion, whether it's proportional or whether here it is proportional to the displacement, or when the acceleration of the ball is not directed towards the center. So for the simple harmonic motion, the acceleration has to be directed. So if you are talking about simple harmonic motion, this knot and this knot here should not be there. But actually, these are the things considered. So for us to now say that this very ball that two people are passing, these two footballers, they pass this ball to themselves. You can see it's making a to and fro motion because it will go here and go here. But now it is not directed towards the center, because this person can apply some force that is even bigger than this person. So the rate at which this one is going is not necessarily the rate at which the ball is getting to this other person. So you cannot say that the acceleration of the ball is directed towards a fixed point. It's not, because it's not even a confirmed straight line movement. And you cannot say that the acceleration of the ball is directly proportional to the displacement from a fixed point. There is no considerable fixed point where you can say that the acceleration is proportional to the displacement. It's not possible, because this person can apply a different force when he's kicking the ball, and this person apply a different force. So there is no surety that they apply the same force. So in that case, you cannot have the acceleration to be proportional, neither can you have this. So these two things that makes something a simple harmonic motion, that makes a simple pendulum, a helical spring, and a plug guitar a simple harmonic motion, here they are put not. So in that case, I and I is the correct answer to this problem. So A is the right option. So A is the right option to this. Thank you. Hello, let's look at this question number 11 for WAEC Physics 2018. Now we have the question: an object at rest is said to possess A, potential energy, B, kinetic energy, C, chemical energy, D, electrical energy. We all know that whenever a body is at rest, that the type of energy possessed is potential energy. That is body at rest. We all know that. And this is energy due to your position at rest in a particular place. Then we also know about kinetic energy, which is energy due to motion, energy of a moving body. Then we know about chemical energy, which is energy in chemical substances. The energy you have in cassava, the energy you have in your food, matter, in form of food or any other thing. That's chemical energy. Then we know about electrical energy, the very refined energy that you can use in your house and everywhere. It's very, very refined. It can easily be transported. This is energy due to electricity and flow of electrons. So those are the various forms of energy. So the one that is for body at rest, or due to height displacement from a particular point, is what we call potential energy. And that is the answer to this problem. An object at rest is said to possess potential energy. If they say object in motion, or object with a moving part traveling from place to place with a speed of, whenever you hear the word speed, moving with a speed, you know it's kinetic energy. Potential energy is energy, chemical energy you see in food, or the basic energy that is in matter due to the bonds in the matter. We call it chemical energy. Electrical energy is energy due to the what? Flow of electrons, or the energy caused by electricity. This electrical energy is highly applicable in so many things. So I'm talking to you now, I'm using electrical energy to power my system and other things. So that is that for this. Thank you. Yes, let's look at this question number 15 for WAEC chemistry, the WAEC physics, 2018. The ice point on the absolute scale of temperature is A, 0 Kelvin, B, 32 Kelvin, C, 100 Kelvin, D, 273 Kelvin. So what is the ice point? For us to understand this, we need to know about the Kelvin and the Celsius temperature scales. Now, in the Celsius, we know that we have the, let's say for water, we have the 100 degrees Celsius for boiling. Then we have the ice point, 0 degrees. Then we also have the absolute zero, which is minus 273. This is for Celsius. So we have the equivalent of all these for Kelvin. Absolute zero here is 0. Then here is 0. Anything you have here is anything here plus 273. So if you say minus 273 plus 273, you have 0. If you say 0 plus 273, you have 273. If you say 100 plus 273, you have 373. So that's the difference between a Kelvin scale and a Celsius scale. Every Kelvin is equal to 273 plus the Celsius. So that's how we got about this, because we added 273 to everything here to get this scale. Now, this is the ice point we know. So the ice point is actually on the Kelvin scale, which is the absolute scale, temperature scale. Always know that whenever you say absolute temperature or absolute temperature scale, we are talking about the Kelvin scale. So what's the equivalent of this ice point in the Kelvin scale? Is going to be 273 Kelvin. So this is in Kelvin, this is in Celsius. So the right answer here is D, which is 273. The ice point is 273. So be very, very careful. You might be tempted to pick 0 Kelvin as the ice point. 0 Kelvin is the absolute zero. That's the absolute zero and not the ice point. Ice point is the point, the ice, temperature of ice, which is solid water. And that is, in Kelvin, it is 273. So take note. And Kelvin is also the what? Absolute scale of temperature. So vapor point or boiling point is this point. So take note of all these. So the right answer is 273 when you are taking it in the absolute scale of temperature, which is the Kelvin scale. You understand? But if you are taking it in the Celsius scale, it will be 0 degrees Celsius. But you can see that everything here is in Kelvin. So that makes the answer to this problem. Thank you. Hello, welcome. Let's look at this question number 16 for WAEC Physics 2018. Which of the following factors does not increase the rate of evaporation of water in a lake? A. Increase in the pressure of the atmosphere. B. Rise in temperature. C. Increase in the surface area of the lake. D. Increase in the speed of the wind. Now, for us to have a very good understanding of this, we have a lake, and this lake has water. As we all know, there's water inside. Now, there is evaporation from this lake. Now, what are the things that will make there to be more water moving from the surface of this lake into the atmosphere? Number one, you will know that temperature does that. Temperature. If you increase the temperature of the water here, they are going to turn into vapor and they will start moving up. So temperature is very, very important. That's number one. Number two is surface area. Surface area of this lake. If this lake had more surface, you understand, there will be more water going up. So this will also increase the amount of water going up. Now, number three thing that will make there to be more water going up is the speed of the wind. Speed of the wind. If we have breeze flowing, heavy breeze flowing, what's going to happen? They're going to push some of this water out of the lake surface and into the atmosphere. So breeze will help move as this breeze is flowing in this direction or any other direction. It will be picking out the water from the top of the lake and be going up. So all these three factors will increase the rate of evaporation. So what will not increase the rate of evaporation is this option A, which is increase in pressure of the atmosphere. If there is more pressure in the atmosphere, it will even force water to get back into the stream. So atmospheric pressure, forces of the atmosphere, will only make there to be lesser evaporation. So that is why the right option is A, that the only factor that will not, take note of what is asked here, not increase. The only factor that will not increase the rate of evaporation is increase in the pressure of the atmosphere. Every other thing here will increase the rate of evaporation, which is, as I've already stated, these 3 points will increase the rate. So the only one that will not is increase in pressure of the atmosphere. Thank you. Yes, let's look at this question number 17 for WAEC Physics 2018. The bulb of a simple pendulum takes 8.0 seconds to complete 10 oscillations. Determine the frequency of the oscillation of the bulb. A. 0.80 Hz, B. 1.25 Hz, C. 7.50 Hz, D. 8.00 Hz. So what is the frequency? Now, for us to understand this very well, we know that frequency by definition is simply the number of oscillations number of oscillations per second.
Me and Oga just spoke now. So I won't forget it.
So number of oscillations over time is frequency. So the number of oscillations that is completed in a second, that's what frequency is. Frequency is the number of oscillations per second. So how many oscillations is able to be completed in 1 second? Now if you take this number of oscillations from this is 10, all over time 8. So if you do this, you're going to get 1.25 as the number of oscillation all over 1 second. So if you divide through by 8 here will give you 1, so that you can get per second, because it's 1 second. Divide this one by 8, you get 1.25. So you can say that 1.25 oscillations was done in what? 1 second. 1 second. You understand? Whereas you had 10 oscillations done in how many? 8 seconds. So if you can do 10 oscillations in 8 seconds, that means you can do 1.25 in 1 second. And the amount of oscillation that you can do in 1 second is the frequency. So the frequency is 1.25 hertz. That is why B is the correct answer, because frequency is simply number of oscillations all over time in seconds. So the number of oscillation here is 10 and time is 8 to give us 1.25 hertz. That is the answer to the problem. Thank you. Hello, welcome. Let's look at this question number 18 for WAEC Physics 2018. The diagram above illustrates the mercury in glass thermometer used for determining the temperature of a room. Use the data on it to determine the room temperature. A 3.3 Celsius degrees Celsius, B 7.0 degrees Celsius, C 13.0 degrees Celsius, D 30.0 degrees Celsius. Now this is the diagram we are considering. So considering this very diagram, we can see that what we actually have is this very thermometer. I have this the mercury that is covered in black. Now we have the tube. Now from the indications, we can see that here we have 0 degrees Celsius, and here we have 100 degrees Celsius. Now from this 0 degrees to the point where you have the mercury level, we have 3 cm. Very, very important. 3 cm. Whereas from this point of 0 to the 100 degrees Celsius side, we have 10 cm. So it's telling us that the total length of this mercury tube inside is actually 10 cm, but the level of the mercury here is 3. So what is the room temperature? And we know that the room temperature is around 25 degrees Celsius. That's the standard room temperature. But if we are taking the measurement here, we have 3 cm, but the room temperature is supposed to be 25. So if you take half of here, if you take half of here, then you're gonna have 5 here and 5 here. That's half. Then if you take half of half, so that you can have 25 here, this is where you can have 25 degrees, which is the room temperature. So you can then read this to correlate. So what temperature can it give, given that here this is the reading? So you can see that the very reading here is somewhere above 25, which we should be assuming to be 30 degrees. So from this sketch, we can say that the room temperature here is 30 degrees from the reading here. So if you divide this, because this is 100 and this is 0, divide it into 2, you have 50 here. So half of 50 is 25, and the reading here is just above this 25, so it should be around 30, because it cannot be this too small, this too small, this too small. And we all know that room temperature generally is around 25 degrees, so it's very, very okay to assume 30 than the other ones. So like I said, here is 0 from the diagram, here is 100, divide it into 2, you're having 50, and you have something that is lesser than 50, which we assume to be 30. So 30 degrees is the most likely close temperature, and that is the room temperature. Thank you. Yes, let's look at this question number 19 for WAEC Physics 2018. Frequency is measured in A, meter per second, B, second, D, hertz, C, hertz, D, farad. So what is the unit for measurement of frequency? We know that number 1, meter per second is for velocity. That's the unit for velocity. Seconds is the unit for time. Hertz is the unit for frequency. And farad is the unit for capacitance. So these are the various units for these various quantities in physics. So whenever you hear meter per second, is simply the unit for velocity or speed. Whenever you hear times in seconds, is unit for time and period as well. Whenever you hear frequency, it is the unit for, or the unit is hertz. That is what you use as the unit for frequency. Farad is for capacitance of a capacitor. So the right answer is C, hertz. Hertz is what frequency is measured in. Hertz is what, that is the unit of frequency. Thank you. Yes, let's look at this question number 20 for WAEC Physics 2018. Which of the following electromagnetic waves is most energetic? A. Radio waves. B. X-ray. C. Gamma rays. D. Ultraviolet rays. Now, if you look at the scale for frequency or any other thing, you're going to find out that on one side you have the radio waves, and on the other extreme you have the gamma rays. So in terms of wavelength, this one has the highest wavelength. But in terms of frequency, this one has the highest frequency, gamma ray has. And the one with the highest frequency also has the highest energy. So you can check the properties of the electromagnetic waves in terms of their wavelength, energy, and frequency. So these are the two in the two extremes. So it can either be gamma rays or radio waves. Well, from what I just showed now, the one with the highest frequency, which is gamma rays, very energetic. It can move. So the answer to this is gamma rays. So you have radio waves. After radio wave, you have what we call microwave. After microwave, then you have other forms of waves like the infrared, the visible light, the ultraviolet, the X-ray, and other ones. So the answer is gamma rays. Yes, let's look at this question number 46 for WAEC Physics 2018. Which of the following particles may be emitted in a process of natural radioactivity? A. Alpha particles and beta particles. B. Alpha particles and X-rays. C. Beta particles and S-rays. D. X-rays and gamma rays actually and X-rays. So now, whenever there is natural radioactivity, the particles that are emitted are alpha particles, beta particles, and gamma rays. Now, natural radioactivity is what happens in our daily life, like when you have, mostly it happens in rocks. And this actually causes uranium to be disintegrated into radon, emitting things like the alpha particles.